are reviewing for our test tomorrow, and I forgot to do a video, so this problem's already done. I'm not going to go over and explain it. That is the correct answer. We're going to go ahead and continue on letter H. We just figured out the domain is between a 1 and a -4. What does the open circle mean? It means it does not include the number. The closed circle means that it includes the number. Thank you for crinkling that paper so it makes that noise in the background. Alright, so we have the set of all x values such that x is less than a 1 but greater than or equal to a -4. That's a horrible graph. And this is called set notation. Right? So now what we're going to do is we're going to talk about the range. For those of you who are watching this video, don't worry. We're going to do a few more problems for you'll get the gist of it. Alright, so right here, the range always deals with how high or how low the graph gets. Remember, the range is always dealing with the set of your y values. So how low does this graph go? -7, you're right. How high up here does it get on the y-axis? +2. So it gets all the way up to a +2 and all the way down to a -7. The number you put here on the right is the biggest number, which is the number 2. The number you put down here is the lowest number, that's the -7. All the y values are between them. So if it says that's an open circle, that means it does not include what number? It does not include the 2. So this has to be less than 2. But it does, right here, it does include the -7 because that point's actually being plotted. So we're going to say it's greater than or equal to a -7. You see the set of all y values such that y is greater than or equal to a -7, but less than a 2. Remember, always put your maximum number there and your minimum right there. Okay? Alright, we're going to do a quick little example of what you need to be aware of, okay? So let's say I had a closed circle and another closed circle, and the graph was being plotted everywhere, somewhere in between us. Okay? What's another combination? We could have a closed circle and an open circle. That'd be another graph that we'd have to worry about, right? What's another combination? We have open. You could have an open and an open, right? And what's the final one that we could have? What are we missing? Open and then closed. Okay. So let's say you have a graph. Okay. And right now I'm just going to practice with the domain. All right. Let's say right now let's just use the same numbers. Okay. So let's say I put this is a -2 and that's a 5, and that's a -2 and a 5 all the way down. I'm just going to use the same numbers. Okay. So how would I write this? X is less than or equal to a 5, but greater than or equal to a -2. That's how you would write this answer. This one would be x is less than 5, but greater than or equal to a -2. So what do you guys think I'm going to do for this one? X is less than 5, but just greater than -2. Now, what do you guys notice so far? When it's closed and closed, you have what? An equal to sign and an equal to sign. Here we have an open and a closed. Here both of them are what? Both of them are open. There's no equal to sign. So what am I going to do here? I'm going to make this what? Less than or equal to? And what about this side? Just a greater. There you're like, now that is a less than sign, but here's how you have to read. So right here, follow the hand. Ready? Follow the hand. This means x is greater than -2, but x is also less than or equal to a 5. That's how you read it, from the inside out. So what does this mean? X is greater than -2 or less than 5. You can also say x is less than 5 or greater than or equal to -2. All right? So right now, these are all the possible combinations that you can have. All right? With the domain. The range is going to either go what? It's going to go up and down. Let's go ahead and do some more practice. It'll make more sense when we do more practice. So here we go. To do this one, once again, I'm going to highlight the domain in blue and the range in red. All right, so we're going to highlight the domain in blue, the range in red. You're going to notice the arrows that I draw. The domain is going to be going from here. It's going to stop right there. And it looks like the range goes from way up here all the way down to there. Like a better arrow. All right. Give yourself a chance to jot this down. All right, let's check out our domain. Where am I over here on the x-axis? Where am I? On the x-axis. Negative 2, so negative 3. Where am I on the x-axis? Right here. Where does that cross go on the x-axis? 2. So here's what you're going to do. All of your x values are between what two numbers? Between a negative 3 and a positive 2. Now, how do I know which symbols to use for this? That's an open, right? That's a closed. So which one's going to have the equal to sign? The one on the left or the one on the right? Which one's going to have the equal to sign? Say that again? Left and right. So this one's going to be greater than or equal to, and this is just going to be less than. So x is less than 2, but greater than or equal to a negative 3. And you just start with the bracket. Set of all x values such. This is the case. Remember, this is your maximum number, right? This is your minimum. Okay? Remember, on your test, it's going to be a multiple choice. So you just got to find the correct one. You just got to be able to interpret it. Okay? If you can write it, if you can create it, you should be able to interpret it. All right, let's think about this. Now, Tristan, you're talking about, hey, how high up do we get on the y-axis? 2, right. How low do we get? Negative 7, okay? So right here, what's our largest number we're going to put as the maximum for our y's? 2. What's the lowest number? Negative 7. So we're going to say the set of all y values such that all of my y values are less than or equal to 2. Why is it equal to 2? Because that's a solid closed in, right? Now, does it actually hit a negative 7 right here? Does it look like it passed through this point right there? Looks like it does to me. So we're going to say greater than or equal to negative 7, and we're going to close it. So here's what I'd like you to do right now. If you're watching the video, pause it and see if you can figure out the 2 answers before we do it. Right now, that's what I want you guys to do in my class. All right, here we go. We're going to start right here with the domain. We're going to start with the domain, which goes all the way from negative 7 all the way over to what number? 2. Oh, messed up. Negative 7 all the way over to a 2. Oh, and work again. 3rd time's the charm, maybe? No? 4th time? There we go. All right. So here's what we're going to start. We're at negative 7, and we're going all the way over to a 2. So you should put this. X is less than 2, but greater than or equal to negative 7. So the set of all x values is such that x is less than 2, but greater than or equal to a negative 7. That is your domain, everybody. Okay? Why is there an equal to sign there? Why is there an equal to sign right there? Yeah, because it's closed in right here. And the reason there's not an equal to sign right here is because that is open. Thank you once again for crinkling up that paper during the video. All right. Now, we're going to go from here all the way down to right there. So how high up do I get? 0. How low do I get? Negative 8. So all of our y values are less than or equal to 0, but greater than or equal to a negative 8. Now, this is where you got to be careful. Okay? Why can I say equal to 0? Because it's not equal to 0 right here, because that's open. But it is equal to 0 right here, because it's closed in. All right? So those are your answers, all in set builder notation. All right? There's the first 2. There's the last 2. All right. Now, everybody, number 2. This is going to be really, really, really easy. You're going to see some questions like this on the test. Could you please write function notation. Function notation. Write this down. Okay? Now, function notation, instead of y equals, you're going to see f of x. And this says f of x equals 6, parentheses, 1 minus x. And it says, what is the value of f of negative 9? F of negative 9, what does that mean? That means all you got to do is plug in a negative 9 for what? We're going to plug in a negative 9 for what value? X, right there. So what are we going to plug in? Right there. We're going to plug in a negative 9. So here's how you would do it. F of not 9, sorry. F of negative 9 equals 6, parentheses, 1 minus, and what am I plugging in for my value for x? Negative 9, I'm going to close the parentheses. So it becomes 6. 1 plus 9 becomes 6 times 10, which becomes what number? 60. That's how you would do it by hand. But you guys have what accessible to you? Calculator. So watch this. You guys hit y equals. Watch this. Y equals. Go to 6. Do an open parentheses. Do 1 minus x. Let's do it all together. Here we go. Ready? Hit y equals. Sorry, I got to clear something out for my algebra 2 class. Clear that out. Clear that out. Here we go. Let's go to y1. Hit 6. Hit an open parentheses. Type in 1 minus x, close parentheses. Just like that. Now let's check the table. Ready? Second window. What do we want to start our table at? We want to start at a negative 9. And let's check our table. Ooh. What is our y value when x is a negative 9? Our y value is at a 60. So if you wanted to, what could you do? You could just go, hit y equals, type it in, and do what? Check your table. Go to y equals, type that in. Now hit second window, and that allows you to start your table directly where? At negative 9. And then hit second graph, which allows you to check your table, and there's your answer. Okay? Now, how would you do it without that? You have to do it, you have to type it in like this. 6, parentheses, 1 minus, open parentheses, negative 9, close parentheses. That's how you would type it in the calculator if you were to type in 6, 1 minus x, where x was what? X was a negative 9. That's how you would type it in the graphing calculator. Okay? That's one way. You could also do that, 6 parentheses, 1 minus a negative 9 like that. You could also type it in without. Well, how do students mess it up? This is what they do. That's what they do in the calculator, and look what it gets. So why do I always suggest that you use parentheses so that the calculator knows that the negative times a negative makes a positive. Okay? Alright, how about this? Why don't you guys find the next one? Here we go. Try the next one. Go ahead. There it is. What are we going to do? We got to find what? What p of 20 is. So what are we going to plug in for this value of x? What's our x value here? 20. So instead of x squared, you're going to put 20 squared plus 1 plus 16. Now that's what you got to be careful of. If that was a negative 20, then you have to put that in parentheses. Okay? So my suggestion is go to y equals 5 parentheses x squared plus 1. I know there's lots of people right now screaming at me. Don't they can do it by hand. Well, you're right. They should know how to do it by hand. Okay? This is how you do it by hand. I'm going to go ahead and put this in parentheses. You get 5 parentheses 20 times 20 is 400 plus 1. So that gives you 5 times 401 plus 16, which gets you 2005 plus 16, which is 2021. Okay? In the calculator, you can do the same thing. What am I going to type in? 5 parentheses x squared plus 1 close parentheses plus 16. So once I type that in, what can I do? Second window. What am I going to type in? The 20. Then what? Second graph. Ta-da! Look at that. Now, should you know how to do it by hand? Absolutely. Okay? But if you have access to a calculator on a fake test where your grade matters, guess what? Use it. Don't be afraid. Use it. 2021? And y equals. I didn't type in the 20 there. I just put x. Okay? But you're right. If I did 5 parentheses and I put 20 squared plus 1 close parentheses plus 16, what is y going to equal at every single point? Every single point, y is going to equal 2021. All the way down. Why are these numbers changing? Because the x values are what? The x values are changing, so the y values are changing. Here, the y value is just staying the same. Okay? All right, everybody. Number 4. Let's look at this carefully. All right? Number 4, we have a table. And it says, which table does keyword not show y as a function of x? So everybody, did you guys write the word function versus relation? Just remember, everything is a relation. Okay? Any set of ordered pairs or any equation will graph a relation. But in a function, put x will not repeat. You can't have the same input, all right, for 2 different outputs. Okay, so you're looking for the one where x is repeating. So right now, in answer choice F, do you see x repeating at all? No. So answer choice F, right. This is an example of a function. How about G? Is x repeating at all? No. So put right here, that's an example of a function. You see anywhere where x is repeating? Where? Negative 0.2, which is negative 2/10, and negative 0.2. If you plug in negative 0.2, you shouldn't get 2 different outputs for the same input. So this is not a function. This is just a relation. And the last one here, notice that says negative 24. That says that's okay. These are all different x values. So this is another example of a function. Okay? So the answer is H. That's the one that does not show y as a function of x. Okay? All right, here we go. Ooh, we have a graph of an exponential function, everybody. We have a graph of an exponential function, and we're going to find the domain and the range of this function. Okay, so let's look at it carefully. Okay? So right now, let's look at the domain of this exponential function. Everybody, this right here, that is the domain. This domain, you can tell, is going to the left forever, and it's going to the right forever. So here's what you're going to write. It's going from negative infinity all the way to positive infinity. So here's what you're going to write for the domain. In this exponential function, it's going to be all real numbers. All real numbers. Okay? Here's how you would write that. The set of all x values such that x is simply an element of the real number system. That means all real numbers are being defined. Now, where is this graph heading up towards in the range? Because the range does not go on forever. It goes on forever, and then it gets down really, really, really close to a number. All right? So it goes way, way, way up. But where's that heading? It's actually heading towards a concept called positive infinity. And what's this getting really close to but never quite touching? It's getting really close to where y is 0. So here's your range. Your range is y is greater than 0. So So you could write it like this. Set of all y values such that y is greater than 0. You could also say, by the way, later on, there's going to be something called interval notation, which you're going to need to know. Not this year, but you're in algebra 2. Okay? Interval notation. You would have a soft bracket, you would put 0, and it's going towards infinity. That's how you would write it in interval notation. Soft bracket means not equal to. Something you need to be aware of in all exponential functions. Okay? In this exponential function, this green line that I'm drawing, this right here, this is called a horizontal asymptote. Okay? So with a little star, there is what's called a horizontal asymptote. Man, yes. Here we go. Better handwriting. An asymptote, everybody, is a boundary. Okay? It's a boundary that's in the graph. And it's at y equals 0, also known as the x-axis. I know like this graph looks like it's touching 0, but in an exponential function, that exponential function will not touch that x-axis. It'll just get really close to it, but it won't touch it. And that's your horizontal asymptote. So everybody, what's the range? The range is y is greater than 0. What's the domain? All real numbers. So if you were to see a graph like this on your test, it's either going to ask you a question about the domain, or it's going to ask you a question about the range. All right. So everybody, we're going to go over 3 questions. Okay? After we do this one, number 6, we're going to go over 3 graphs. Linear, quadratic, exponential. We're going to talk about the domain and the range for all of those. Okay? So we have 2 more problems to do. Number 6, and then we're going to graph a linear, a quadratic, and an exponential. Can you guys go ahead and make a table for me? We talked, the table's already here. Just remember, h of x stands for your y values, okay? Here we go. Make a table going vertically, not horizontally. It's easier to see. Here we go. -4, 41. -2, 17. 0. And a 1. 2. And a -7. 3. -8. 4. And a -7. 6. And a 1. You should look really carefully right now. Now, in this quadratic function, okay? Now, a quadratic function will either open up like this, or it will open down like this. If it opens up, this point will be known as the minimum. This vertex of a parabola will be known as a minimum. If it opens down, this vertex will not be known as a minimum. It will be known as a maximum. So everybody, it says, what is the range of h? So I'm going to highlight just the range. Does everybody understand that the range is your y values? So check it out. You go from 41 to 17 to 1 to -7 to -8, then back to what? -7, then to 1. Everybody, this right here, this is your vertex. How do you know it's your vertex? Can you guys see how these are the same? And these numbers right here are the same? Okay, so that lets you know that's your vertex. What's the absolute lowest number that I get? -8. So the answer is all real numbers greater than or equal to -8. That's the range, which means this. Y is greater than or equal to -8. That would be your answer. That's how you write greater than or equal to -8. Now, what are the 3 functions that you guys need to be aware of for tomorrow? Linear function, quadratic function, and exponential function. Okay? So everybody, here are the three functions that I'm going to draw out real quick. If I say y equals x, what kind of function is that? Linear. By the way, in a linear function, the domain and the range is all real numbers. Okay? So right now, before you guys leave, what's the domain and what's the range for this function? All real numbers. Okay? We put all capital R. If I said y equals and I type in x squared, what's the domain? The domain is all real numbers. The range is y is greater than or equal to 0. That's the lowest that it gets. Last one. Y equals 2 to the power of x. Before you guys leave, let me do one last one. And I'll let you guys leave. If I can just delete that, good. Oh, go to delete. Here we go. See that function right there? The domain is all real numbers. The range is y is greater than 0. Okay? So those are the three functions you need to be aware of tomorrow.